Hello, welcome to this video on vitamins. Hopefully this should be a pretty straightforward one for us, so let's get started. So basically we're going to be covering all of these points. So we're going to talk about what vitamins are, looking at their structures, particularly by comparing vitamins A, C and D. We're going to talk about heat sensitivity, particularly in the context of vitamin C. And we're going to talk about vitamin deficiencies and what we can do to help. The images I'm going to use of vitamins A, C and D are directly from the data book. And while I am going to mention some deficiency diseases, you don't need to know their names. All right. So, definition of vitamins. The term vitamins originally comes from vital amines. It was thought that originally all vitamins were those amino acids. They're micronutrients. They're called micronutrients because we don't need much. So, for example, if you look at the nutritional labeling on the side of like a dissolvable vitamin C tablet, it will tell you how many milligrams are needed each day. For the most part, we aren't able to make these ourselves, so must be ingested. So ages ago when I was talking about amino acids, I called some of them essential amino acids because our bodies couldn't synthesize them. Same thing goes for most of the vitamins. We have to ingest them. Now, when we talk about vitamin A, B, C, D, E, and K, I don't know why we jump, but when we talk about those categories of vitamins, not every single form of vitamin D looks the same, but we categorize them by their properties. So all of our vitamin Ds are, I believe, steroid derivatives. And they're all fat soluble, not water soluble. Also, for example, all of our vitamin C, actually there might only be one vitamin C. Vitamin C is water soluble. Okay, let's continue on. So for vitamin A, and as I said earlier, this image is directly from the data book, all the way up the end. This is a picture of what vitamin A looks like. It's super important, but you don't need to know why, that we have these alternating double and single bonds. The word retinol comes from, if you remember like year 8 science, from the retina. Now the retina is that light sensitive layer of cells at the back of the eye. And retinol is an important part of how the retina functions. It's something that we would be talking more about in HL. Let me just switch to my highlighter. Now, let's talk in terms of solubility, and hopefully you can see where I'm going with that portion of the molecule I've circled. Sorry, I'm just having a snack. So this is non-polar. So you've got this big non-polar section here, and you've got this eensy-weensy polar bit at the end. So overall, this is a non-polar molecule. And you might have heard about, or your parents might have told you when you were a kid, that you had to make sure you eat your carrots so you could see properly? That's because carrots are actually a really good source for retinol. Now, when you've got these ring structures and this quite strong carbon chain, sorry, I've forgotten. Yes, okay. So when you look at the stability of this structure we've got, it's actually fairly resistant to being damaged by heat. So some vitamins get broken down with heat. Vitamin A is remarkably resilient to that. So, for example, if you look at overboiled, mushy carrots, they have roughly the same amount of vitamin A as carrots in a salad. And it's because of the stability of that chemical structure. What you need to be able to do for the IB is look at that overall picture and say that it would be soluble in fats, and then explain why. Okay, let's move on. So vitamin C is one of the vitamins that you've probably heard of before. So ascorbic acid is found a lot in citrus, but also in other sort of leafy fresh things. It's fairly widespread. Now, let's look at this structure, thinking in the context of solubility. I've got a polar group here, polar group here, polar, 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 polar. Overall, vitamin C is water soluble. What that means is it's a difference in how you can take supplements. So things like you can get dissolvable vitamin C tablets, but for vitamin D, if you've got a vitamin D deficiency, you need to take like oil-based capsules. That's the difference we're talking about. So vitamin C is water soluble, and the deficiency disease for vitamin C was actually identified well before we knew anything about the chemical structure of this thing. So the deficiency disease for vitamin C is called scurvy. It's a condition that used to overwhelmingly affect a number of people, but perhaps most famously sailors, because on long sea voyages in the past, you couldn't have fresh foods, and it's fresh foods that tend to have vitamin C. So remember what I said about I knocked my mic. Remember what I said about vitamin A, that it was fairly resistant to heat damage? One of the issues with vitamin C, and one of the reasons why it's considered to be a deficiency disease of lack of fresh food, vitamin C is water soluble and it's susceptible to heat damage. I was trying to think of the word. Susceptible to heat damage. One of the most standard IAs is to test what is the effect of temperature on vitamin C concentration in name a foodstuff of your choice. I've marked 7 or 8 of them over the years. They're a perfectly decent IA topic, but there's not terribly much new or interesting there to discuss. So vitamin D, really important, and it's one of those ones where the deficiency disease is kind of better known than the vitamin itself. Let's continue on and talk about our last vitamin. Okay, so vitamin D, I actually discussed in the steroids video. If you remember, this central section is the B ring of a steroid backbone. So it's that modified 4-ring fused structure from a steroid backbone that we see in a vitamin D. So as I said before, while there is highlighter blue, this little polar section off to the end here, much like vitamin A, it is fat soluble. Because of this very large non-polar component. So vitamin D deficiencies have been linked to a number of different things. It has a connection to, so vitamin D deficiencies have been linked to difficulties with calcium management in the body. So with our vitamins, let's talk about deficiencies in general. So deficiencies in general can be caused by a couple of different things. Issues with nutrition. And that doesn't necessarily mean starvation. One of the things that's actually really concerning as food security becomes increasingly unequal in the world. We're starting to see children in parts of Australia and in parts of other Western, quote unquote, first world democracies, where you've got kids that are suffering from scurvy just because fresh fruit and veggies are so expensive. And families can't afford to give that kind of food to kids, or can't afford the time to prepare fresh food and fruit and veg for meals. So vitamin deficiencies are generally caused by poor nutrition. Now, what can we do to fix it? So we could change food prices. We could give like supplement tablets. But one of my favourite ways we could treat this, and this is just me being a massive science nerd, are GMOs. There is a GMO variant of rice called golden rice, and this rice is literally yellow. So think back to what I was saying about vitamin A. Vitamin A is super important for maintaining the health of the retina. Vitamin A deficiency can cause issues with vision. So golden rice is a GMO variant of just normal white rice, where a gene has been added so that rice, as it grows, produces more vitamin A, and it actually turns the rice yellow. So in environments where rice is a staple grain, it's not a grain, a staple crop, where there might be vitamin A deficiencies, something like golden rice is really important because it gives access to the vitamin A without necessarily being a supplement tablet. It's something that can be grown and propagated, and it's something that stores really easily. Like we've seen at the moment with all of the coronavirus stuff, pasta, rice, legumes, they've all sold out. It's because it's something that can be stored for a long time and transported really easily. And that's another advantage to something like golden rice as opposed to something like fresh food, which doesn't store as well, doesn't last as long. So vitamin deficiencies, I mean, depending on what they are, they can be treated in various ways. You can equally have vitamin poisonings. So one of the really interesting things that used to happen to the Arctic and Antarctic missions is that as the sled dogs died and as the food ran low, the teams would eat the dogs, which, but one of the other issues is they would eat the livers of these dogs. Now, vitamin A tends to be stored in the liver. So a lot of the time, these missions would end up, people would be having some pretty severe side effects from vitamin A poisoning. So just like anything else, like we're 60 odd % water, but we can still drown. We need these vitamins, but we can still be poisoned by them if there's too much. Okay. So what we've discussed today, we've talked about what micronutrients are. We've talked about that they can't be synthesized by the body, but have to be obtained from food sources. Ka-ching. We've talked about water or fat solubility, looking at structure. We've talked about heat sensitivity. And we've talked about vitamin deficiencies. Yes. We've talked about vitamins A, C, and D. So, causes and effects of vitamin deficiencies and suggestion of solutions. We've discussed that. So, structures are given in the data book, Ka-ching. And while I mentioned some specific food sources and names of deficiency diseases, you don't need to know those. So, yes, that just about brings us to the end of this video. If you've got any questions, please let me know. And I will see you next time. Have a fantastic rest of your day, and I'll see you soon. Bye.